Hello and welcome to Physics World. In the mid-50s, the integrated circuit revolutionised electronics, making more and more sophisticated technology based on several transistors not only possible, but smaller, cheaper and faster. For decades, the number of transistors per chip doubled every 2 years, a relation first highlighted by Gordon Moore and soon coined as Moore's Law. On the 18th of July 1968, alongside Robert Noyce, Moore co-founded a company focused on integrated electronics. The company, Intel, remains a household name. 50 years on, we spoke to researchers in academia and industry about some of the developments emerging in the field today and some of the future of electronics that they find most exciting.
I'm an applications engineer with Novacentrics in Austin, Texas. We're a company of about 75 people.
My name is Wenzuo Wu, and I'm an assistant professor at the School of Industrial Engineering at Purdue University in West Lafayette.
I'm Luisa Torsi. I'm a professor of chemistry at the University of Bari, Italy, and the immediate past president of the European Material Research Society.
I'm Eleonora Macchia. I come from University of Bari, and I'm an early postdoc in Professor Luisa Torsi group.
So I'm Steve Beebe from the University of Southampton, and my research is in printed electronics and e-textiles.
Yeah, I'm Klaus Hecker, Managing Director of the OEA, an International Association for Organic and Printed Electronics, companies who are active in that field with members worldwide, so we represent the entire value chain of this new and emerging industry.
Highlights of this conference I really like the most are about energy harvesting, which I think it's one of the applications for flexible electronics, particularly when it's combined with textiles.
So I'm basically very interested in putting electronic functionality into textiles for numerous applications in healthcare and military applications and things like this. So a form of wearable technology. I think e-textiles have been around for a long time, but they've been sort of characterised by sort of almost like a hobby approach of manually weaving or embroidering conductive wires and things. And I think what's driving it is applications in healthcare, for example, where you can integrate healthcare monitoring functionality into garments.
I'm involved with bioelectronic sensors and the study of interactions between biological layers and external stimuli, particularly affinity compounds and molecules.
I'm just finished my PhD on biosensing platform for printable biosensing platform, let's say, for early diagnosis of diseases such as cancer or...
My research interest is primarily focused on designing and synthesizing and eventually manufacturing reliably new functional materials and integrate them at large scale for functional applications. For example, in human-machine interface, human integrated technologies, wearable devices and sensors.
We make state-of-the-art photonic curing tools, highly conducting metal inks, and we also provide a variety of services for customers who are looking to design and develop some kind of printed electronics.
So with the Internet of Things and the need for sensors and, let's say, intelligence on everyday items, there is a big movement right now to bring printed electronics, starting with NFC labels here and then further adding additional functionalities like sensors.
Currently, there have been numerous, huge amount of fantastic work exploring and understanding the fundamental science and the concepts in all the nanomaterials, including nanowires. But I think in order for the entire community to push it forward, to make something real, impactful to society, we must be able to come up with an economic approach or platform or platforms to integrate those nanomaterials synergistically into a designed structure as per your design.